So in some fields, we are the leaders, but in industry, generally speaking, in fact, it is restricted. It is not used, and you cannot use it as private or even national companies. Now, if I come back to your presentation, there is one question maybe. In general, we do this test in aerated ambience, that means in the presence of oxygen. We irradiate our materials. And we may get, let's say, processes like, for example, transition or cross-linking at the same time, or one dominant over the others. But my question is, if you try to use polymers, which are different from structures or even in blends of polymers, how can you manage to avoid, for example, if you are looking for cross-linking or if you are looking for degradation, how can you manage this problem? How can you, for example, determine exactly what is the dose corresponding to cross-linking or to degradation by chain scission, for instance?
Yes. Actually, in my facility, we don't do cross-linking activities. As you know, Dr. Mustafa, the gamma radiation has a low energy photon, 1.3. And the photon emission rate is very low. Generally, if we are going to make a business from cross-linking, we need an electron beam, a high energy electron beam accelerator, which can reach 10 MeV, and the dose rate, as you know, 25 in seconds, 70s, 100 kilogram may be done in seconds. I think I'm just giving some notes. It's not a real answer to your question. For example, in Europe, there are a lot of electron beam accelerators give the radiation service. Mainly, they get the big amount of money by cross-linking polymers and sterilizing medical products the way we do in Jordan is a byproduct. They just cover the expenses, but the main profit or the main product is by cross-linking polymeric or plastic tubes. As I mentioned in the beginning of my presentation, you put plastic tube from this side, you end up with semi-stainless steel tube from the other side, which could be very interesting for chemical production, so and resist high temperature and high pressure.
We have time for a last question, yes.
Thank you, Professor, for your presentation. Please can you go back to the mechanical properties slide? I just need to know what's happening, why there are decrease and increase with different dose.
This one. The problem, as you see in this slide, you see that the most affected is the benzene ring. It disappeared. Is it broken or becomes part of the chain? I think we need to investigate more about this, but generally it is an impression. The impression is good. there is no contradiction in these results, but still, we have to know why the tensile strength increased and decreased. So maybe the benzene ring becomes part of the chain or disappears, then return back, because it's the dose means excessive energy. Once you make the cross-linking and finish with the cross-linking, maybe the energy will be used for making the session. And actually, in reality, there are both. There is no cross-linking or session alone. Both of them are working together, but one of them is dominant. For example, 60% cross-linking and 40% session. So we say cross-linking, but still, in fact, there are session and cross-linking happening in the same time. So maybe this will answer the question, but really the question should be answered more precisely and scientifically, maybe later in the our research.
Thank you so much. Anyways, we have to move to the next session. Thanks a lot for your presentation, and thanks for all the presenters this morning. So I guess you have the microphone for the sharing the next session. That's you're the chair. Oh, no.